Mosaic is a middle-tier architecture that orchestrates data views and backing databases, unifying scalable visualization techniques within visualization languages. Here we use Mosaic to explore 1.8 billion stars in the Gaia catalog. Selecting higher parallax stars reveals the main sequence of stellar lifespans in the plot of color versus brightness on the right. We can trace this sequence to see how those stars distribute in the sky map on the left. The distribution appears relatively uniform until we brush down to the brightest stars. Mosaic provides a standardized selection abstraction for linking across tables, visualizations, and input widgets such as sliders, search boxes, and menus. All of these components are linked via dynamic parameters and coordinated queries. Computation of regression models, interquartile ranges, and other transformations are automatically pushed down to the database. A Mosaic application consists of data-driven clients that publish their data needs as declarative queries. The Mosaic coordinator manages these requests and submits queries to a backing database. By default, we use DuckDB, a scalable open-source database. Query results are then returned to clients for rendering. To transport data, we use Apache Arrow, a binary format that enables efficient transfer with no subsequent parsing overhead. Mosaic also mediates linked interactions. Updates from clients or interactors populate dynamic parameters such as selections, which manage multiple filtering predicates. Selections resolve updates across multiple clients, supporting techniques such as cross-filtered views. To assess Mosaic, we also designed VGPlot, a grammar of interactive graphics. In VGPlot, each mark is a Mosaic client that generates queries. For example, we can create this chart using an area Y mark. A basic query selects all data points, here resulting in 50,000 rows. In Mosaic, the area mark instead applies M4 optimization, performing pixel-aware binning to reduce the data by over an order of magnitude. Now let's create an overview plus detail interaction. We duplicate the area chart and then coordinate charts with a selection. The top chart includes an interval interactor to filter the bottom chart. We can now explore the data with M4 optimization applied on every update. Here we visualize 10 million flight records as histograms. We bin along the x-axis and visualize counts per bin on the y-axis. We add a selection with cross-filter resolution and add interval brush interactors. As we select longer arrival delays, we see those flights are more likely to leave later in the day. And rather than re-query the full table on each update, the Mosaic coordinator analyzes queries to automatically generate data cube indexes, here binning over all pixels the brush endpoints may occupy. Then on each update, we instead query the pre-aggregated data cubes, providing substantial speedups. To evaluate scalability, we conducted performance benchmarks comparing Mosaic variants to Vega, Vega Fusion, and Observable Plot. Mosaic provides order of magnitude improvements for the initial rendering of aggregated bars, linear regression plots, two-dimensional histograms, and area charts. Other tools fail to render area charts with millions of data points. Mosaic also provides superior performance for density contours and hexagonal bins. We evaluate interactive performance on real-world datasets ranging from millions to billions of records. Data cube indexes can be built on the fly for up to hundreds of millions of points, but beyond that, pre-computation is desirable. With indexes in place, Mosaic supports real-time interactive updates, even between high-resolution raster visualizations. As described in our paper, other popular tools and optimizations fail at this scale. In conclusion, Mosaic supports expressive, extensible, and interoperable data views that compose diverse visualization, interaction, and optimization techniques. Mosaic applications can be specified in a portable, declarative format, enabling rich integration with environments such as Jupyter Notebooks. We hope Mosaic can serve as a promising open-source platform for the research and development of scalable, interactive data systems.